Lesson 5.3, we're going to do double angle and power reducing formulas. The double angle formulas are given in your book and they are as follows. The first problem we're going to do is going to have the sine of theta is equal to 4/5. Theta lies in quadrant 2 and we want to find the exact value of the sine of 2 theta. So using this formula here, that the sine of 2 theta is 2 sine theta cosine theta, I'm going to want to plug in the sine of theta, which is given, so it's just 4/5. But then this needs to be the cosine of theta. So where am I getting that? Well, I'm getting it from making a right triangle and setting up the sine of theta is equal to 4/5. Because that's what was given. Using the Pythagorean theorem, I can find out that this is 3 because I'll do a squared plus 4 squared equals 5 squared. So that's how I get that this is 3. The cosine then would be the adjacent over the hypotenuse. But in quadrant 2, keep in mind that cosine and tangent are both negative. So that's why I'm getting a negative 3/5. Multiply those together and I get negative 24/25. Then for the cosine of 2 theta, I'm going to use this formula, cosine squared theta minus sine squared theta. So once again, we already know the cosine of theta from the last problem. This was given. Square it, and then subtract, and it's negative 7/25. Then for the tangent of 2 theta, I use this formula here, 2 times the tangent of theta over 1 minus tangent squared theta. The tangent is the opposite over the adjacent, and once again, it's negative because in quadrant 2, the tangent is negative. So 2 times negative 4/3 is negative 8/3. Square this, that's going to be 16/9. 1, I need a common denominator, so it's 9/9 minus 16/9 is negative 7/9. We divide fractions by multiplying by the reciprocal, and that's how I get 24/7. In example 2, find the exact value of cosine squared 15 degrees minus sine squared 15 degrees. So I'm going to use the reverse. I've got this set up with theta being 15 degrees. So that's equal to the cosine of 2 theta. So the cosine of 2 times 15 would be the same as the cosine of 30, which, using your 30, 60, 90 right triangles that we talked about in the previous chapter, would be radical 3/2. To verify an identity, sine of 3 theta equals 3 times the sine of theta minus 4 times the sine cubed of theta. First, I'm going to write the left side of the identity. That's what we always do when we verify it. Rewrite it. Then I'm going to break up 3 theta into 2 theta plus theta. In our previous chapter, we had a theorem that the sine of alpha plus beta is equal to the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. So I'm going to use this with alpha being 2 theta and beta being theta. So that's how I'm getting this step here. Now my goal is to have everything left in terms of sine. So I have to try to do some substitutions to make that happen. So the first substitution I'm going to do is the sine of 2 theta being equal to 2 sine theta cosine theta. So I do that. That's here. And then bring this down. And then the cosine of 2 theta, I use this here, plug that in, distribute the sine, and then I'm going to simplify this by multiplying it together, and it's cosine squared theta. and then this I distributed, and that's how I get this. Now back in the previous chapter, we learned that the cosine squared theta is equal to 1 minus sine squared theta. So first, I'm adding together these like terms. 2 of these plus 1 of them is equal to a total of 3 of them. Then I use the Pythagorean identity to replace cosine squared theta with 1 minus sine squared theta. So now I'm all in terms of sine. And then this sine cubed theta, I just keep bringing it down. At this step, go ahead and distribute the 3 sine theta. And then notice I have like terms that I can put together. And then that is now equal to this. Then we have our power reducing formulas. Sine squared theta, cosine squared theta, tangent squared theta. So we are going to write an equivalent expression for sine to the 4th of x that does not contain powers of trigonometric functions greater than 1. So first I'm going to write the sine to the 4th of x as the sine squared of x squared. Then I'm going to use the power reducing formula and replace sine squared x. Then at this step, I'm going to square this fraction. So the denominator squared would be 4, but the numerator squared, I have to do 1 minus cosine 2x times 1 minus cosine 2x. That has to be FOILed out. So that's how I'm getting this right here. I'm FOILing it out. From here, I'm going to divide each term by 4 so that I can write it as 3 separate terms. So that's how I get this. 1/4 minus 1/2 cosine 2x plus 1/4 cosine squared 2x. These two terms I'm going to rewrite for right now, but this, I'm going to use this formula to rewrite it. So instead of cosine squared 2x, I'm going to do 1 plus cosine of 2 times 2x, which is how I'm getting 4x over 2. From here, I'm going to take 1 divided by 2 and cosine 4x divided by 2, so that I'll have 2 terms. Multiply both of those terms by 1/4. So rewrite this. That's what I did here. I rewrote those. And the 1/8 comes from taking 1/4 times 1/2. And then the 1/8 cosine 4x comes from taking 1/4 times 1/2 cosine 4x. Collect like terms by finding a common denominator. So this is 2/8 plus 1/8 is 3/8. Then just bring these down. Minus 1/2 cosine 2x plus 1/8 cosine 4x. And then we're done because we don't have any powers greater than 1.